morning, everyone. Today we are studying Chapter 8. Now, Chapter 8 is applying exponent properties involving products. Now, if you remember, products mean multiply. So today we're going to be multiplying exponents. So, when we are multiplying exponents, now I don't want you to multiply everything completely and get a giant number. If we go back to the learning target, this says we want to simplify expressions, not solve. So if we go to this first one here, we have 7 to the third power times 7 to the fifth. Now what that is saying is that we have 3 7s on this side, 7 times 7 times 7, and 5 7s on this side. So if we count those up, 1, 2, 3, 4, 5, 6, 7, 8, we have 7, 8 times. That's all I want you to do. I want you to simplify this. That's all we're doing is counting up how many numbers we have. Here we just have a 9, and if we just have a 9, that means we only have one of them. So for this one, we have 1 9. Here we have 8 9s. And here we only have 2 9s. So when we're multiplying these, we can add up our exponents. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 9s. Next one we have some parentheses, but those shouldn't matter. Here we're just saying we have 1 -5 and 6 -5s. So if we write those out, we have 1 -5 and then 6 -5s. So we have 1, 2, 3, 4, 5, 6, 7 -5. So remember, we have to keep these parentheses because that 7 is multiplying the whole -5s. Next one, we just have x's, but we're just saying that we have 4 x's. So x, 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 and x. This one we're saying we have 3 x's. So 1, 2, 3, 4 x's plus 1, 2, 3 x's gives us x to the 7th power. Alright, now we are using the power of a power property. So this time we have an exponent on the outside of some parentheses, and in those parentheses we have a number with another exponent. What this is saying is that we have 3 2/5, or 2 to the 5th power, I mean. So 3 2 to the 5th power. Now we're multiplying these together. So we have 3 of these. Now each of these is saying that we have 5 2's. So 2, 2, 2, 2, and 2. 2, 2, 2, 2, 2, and one more, 2, 2, 2, 2, and 2. So if we just count these all up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 2's. So 2 to the 15th power. Now some of you may have noticed that we could have just taken this 3 times the 5 and got 2 to the 15th. Yes, that would work. I'm just showing my work here, and you're going to need to show your work as we go along here. So this one over here, we have brackets and we have parentheses. This is saying we have 5 -6 to the second powers. So I'm going to write that out. -6 to the second power times -6 I'm going to write this 5 times. So now each of these is saying that I have 2 -6s. So I would write -6, -6, -6, -6, and so on. So how many -6s do we have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So remember to put your parentheses still, -6 to the 10th power. Now we could have just done 5 times 2, but I'm just showing you how to show your work for these problems. Here we have 4x to the seconds. So 4x squared. So x squared times x squared times x squared times x squared. So we would have 2 x's in each of these. So we have 8 x's total, so x to the 8th power. Now, this is where it gets a little bit trickier. Here we have y plus 2 to the 6th power times by, that whole thing squared, so 2 of those. So I would have y plus 2 to the 6th power twice. Now, what this is saying is that I have 6y plus 2's, so I could write these all out. But then I would run out of room and it'd be a lot of writing. So what I'm going to do is just going to say that 2 times 6 then would be y plus 2, 2 times 6 would be to the 12th power. So now I can't simplify this anymore because this is a plus sign and not a multiplication sign. So we just have y plus 2 to the 12th power. Now, the power of a product property. Now, before I said we couldn't multiply or couldn't simplify because it was an addition sign. Well, now we have a multiplication sign. So what this is saying is that there is 8 24s and 8 13s. So I could write that out, 24 8 times. And 13 8 times. So what I would have then would be 24 to the 8th power times 13 to the 8th power. Now that would be a huge number to multiply together. So I think I'm just going to leave it like that. So next one. This is saying we have 2 9xy's. So 9xy times 9xy. What this is saying is that I have 1 9 here, 1 x, and 1 y. Same thing here, 1 9, 1 x, and 1 y. Now, well, how many 9's do I have? Well, I have 2 9's, I have 2 x's, and I have 2 y's. So, I could leave it like this, Or 9 squared is pretty simple, so I could just write it as 81 x squared y squared. Next I have two negative 4z's, so negative 4z times negative 4z. So I have one negative 4 here, one negative 4 here, and one z, one z. So two negative 4's. If I do negative 4 times negative 4, that gives me a positive 16. And then z times z will be z squared. Here we have a negative 1 outside of our parentheses. So what we're going to do is we're going to take that negative 1 and we're going to multiply it by our two 4z's. So 4z times 4z. Now if I were to write that out then, I would have negative 1, 4 and a z, and 4 and a z. So we would have negative 1 times 4 squared z squared. Negative 1 times 16z squared would be a simplify. And then I could just simplify that. So negative 16z squared. Alright, now it gets to be a lot of numbers and letters and exponents. So it's going to be best if we write this all out. So what we are going to do now is we're going to see how many of these we have. So we have 2x to the thirds. So 2x to the third times 2x to the third. And that's being multiplied by x to the fourth. So here we have 1, 2, and 3 x's. This one we have 1, 2, and 3 x's. Here we have 4 x's. So what we have then is 2 2's, so 2 to the second. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. So we could simplify that. 2 times 2 would be 4, and then x to the 10th. Here we have a 5 outside. And we have 4 5x squareds. So 5x squared times 5x squared times 5x squared and 5x squared. So here we have 1 5, another 5 here, 2 x's, 5 here, 2 x's, 5 here, 2 x's, and a 5 here, and 2 x's. So right now we have 1, 2, 3, 4, 5 5's, so 5 to the 5th power. And we have 1, 2, 3, 4, 5, 6, 7, 8 x's. So our answer would be 5 to the 5th power times 8, or x to the 8th power. Here we have 4 9m cubed times n. So 9m cubed n times 9m cubed n times 9m cubed n times 9m cubed n. So if we counted these all out, we'd have 1 9, 3 m's, and an n. 1 9, 3 m's, and an n. 1, 9, 3 m's, and an n, 1, 9, 3 m's, and an n. So altogether, we have 9 to the 4th power times m to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12th power, and n to the 4th power. Here's where it gets a little bit more tricky then. We have 2 negative 20x to the thirds, so negative 20x cubed times negative 20x cubed. And we also have negative x to the 7th power. So what we have then is 1 negative 20 here and 3 x's, a negative 20 here and 3 x's. And what we have here is actually a negative 1. So we have a negative 1 and 7 x's. So if we were to multiply this then, we would have negative 1 times negative 20 squared. And 3 x's plus 3 more x's, that's 6, plus 7 is x to the 13th. Now we can simplify this to 20 times 20, which is 400. So negative 1 times 400 x to the 13th. And we could finally just simplify that to negative 1 times 400, which would be negative 400 x to the 13th. Alright, now we need to find a missing exponent. So we see we have a question mark on some of these, or all of them. So we need to figure out what is that question mark. So what I'm going to do is here I know that I have 5 x's. That's my total x's. Here we have 4 x's. So I know that I have 4 out of the 5, so I could cross those 4 off, cross those 4 off. What I'm left with is just 1x. So my question mark must be 1. Here, because we have parentheses, this is saying a group. So what we have is a group of 8 y's. So we have a group of 8 y's here. How many groups do we need to get 16 y's? Well, I know that 8 times 2 is 16, so my question mark must be 2. Here we're saying how many groups of 3a to the 3rd power do we have? So this is saying we have an 18 and 9 a's. That's our total. That equals a 2 and 3 a's. And here we have a group of 3 and 3 a's. Well, I know that I can get rid of these 3 a's and get rid of those 3 a's because that cancels out. Now, I'm left with 6 a's, so I need 1, 2, 3, and then 3 more a's. So that would give me all my a's, but then if I multiplied and made another group of these, I would have to put a 3 there. So 3 times 3, that's 9, times 2 is 18. That works. So my question mark here is 2. Last one here, we have 3 groups of 2z something equals an 8 and z 15 times. So 2 times 2 times 2, that's 8. So we need to figure out what or how many groups. Well, we have 3 groups, so I could just take this group, and this group, and that's telling me that there's 5 z's in each. So our question mark has to be 5. Last problem, it says the metric system has names for very large weights. A, 1 gigaton is 10 squared times the weight of 1 hectoton. 1 hectoton is 10 squared tons. Write 1 gigaton in tons. So we got to take our hectoton, which is 10 squared. Our gigaton is 10 to the 10 squared times the weight of a hectoton. So times 10 squared. So that's saying we have 4 tens. So 10 to the 4th is 1 gigaton. Now it says a teraton is 10 to the 9th times the weight of 1 kiloton. 1 kiloton is 10 to the 3rd tons. Right, 1 teraton in tons. 1 kiloton would be 10 cubed times 10 to the 9th. So 1 teraton is going to equal 10 to the 12th. Last one, 1 exacton is 10 to the 6th times the weight of a teraton. Use your answer from part B to write 1 exacton in tons. Well, we said a teraton was 10 to the 12th, and that 1 exacton is times 10 to the 6th, so 1 exacton must be 10 to the 18th